All right, more practice problems. I want to do a quick example about going over some basic definitions and properties about functions. Talked about functions a little bit in the very beginning, but here I want to give a nice example of an interesting function and then just ask a bunch of questions about it. So consider the function from the real numbers to the real numbers defined by, so if x is our input, first of all, if x is irrational, it gets sent to 0. If x is rational, it gets sent to 1 over s. If x equals r over s, in lowest terms, and s is greater than 0. So let me make a quick comment. If you make these two conditions, that r over s is in lowest terms and s is positive, then you have a unique expression of each rational number this way. So that's why it makes sense to put this here. And also the only questionable example is what you do with 0, and let's just say that's 0 over 1. Seems like the natural choice. So let me ask a bunch of basic questions about this function. But actually, let me first say, why is this an interesting function? If you're familiar with your calculus, this is a really nice example of a function that is, let's see, this function is continuous at irrational numbers and discontinuous at rational numbers. So it's a really weird example of a function that has discontinuities on a crazy, like, everywhere kind of set. It is discontinuous at every rational number. But it's continuous near irrational numbers, which is very strange. Am I saying this right? I think I'm saying that right. Yeah. Anyway, yeah, it's a very interesting example of a function. But let's ask some questions. So what are the domain and codomain of f? These are basic data of any function. And in this case, or usually in any case, you can read them off from the definition. So you just need to remember that the domain is the thing the function is mapping from, and the codomain is the thing that the function is mapping to. In this case, they're the same, but they don't have to be. What is the image of, let's say, what is the image of 1/2? So remember, image is something that you can ask about various things. You can ask about the image of a point, like we're doing here. You can ask about the image of a subset, or you can ask about the image of the whole map. And by this, we mean the image of the whole domain. So let's run through each of these things. What is the image of 1/2? Well, if we write it in low, so first of all, it's a rational number. And then if we look at the relevant section of this definition, which is the top part, we see that we write it in lowest terms, r over s, with s greater than 0. It is written like that already. And then we take 1 over s. So that is the answer. F of 1/2 is 1/2. Although if we do, if we want to take more examples, what is f of 3/2? Well, remember, we get rid of the top part and replace it with a 1, so actually it's, again, 1/2. What is the image of the integers, which are a subset of R? So an integer the way we write this in lowest terms with positive denominator is just to write n over 1. So f of the integers, this is going to be a subset. So if you plug in a particular element, you get a particular element. If you ask about the image of a subset, you will get a subset. But in this case, the subset only has one element, because every integer maps to 1. If you wanted to ask about, for example, f of what should I say? N over 2. This, just to say this is like integers and half integers. So it's like -1/2, 0, 1/2, 1, 3/2, 2, etc. The image of this would be, well, it's basically the denominators that you're getting. So we still have 1, but now we also have 2. And what is the image of the whole map F? Well, let's go back to the definition. It's got to include 0. And it's also got to include 1 over s, wherever we can write x as r over s, a rational number. So it includes 0 and 1 over s for any s greater than 0. Or I should say for any integer. And that is everything. So the image how can we write it? Well, let's try writing it a couple of different ways. Well, let's just write it one way. It's 0 union 1 over s, s a positive integer. What other kinds of questions could we ask about this? What about preimages? What is the preimage of 1? So remember, an image, every element has exactly one image. But preimages, you can have none, or 1, or many. So if we're talking about the preimage of a point, we usually mean that as a set, because it could have more than one element, or it could also be empty. So what is the preimage of 1? Well, this will not affect it, so we can ignore that. This part how do we get a 1 out of this? It's when our rational number in lowest terms has a 1 in the denominator. And that is exactly when it is an integer. So I guess we saw before that the image of the integers is 1. And the opposite way, it's also true. The preimage of 1 is the integers. Although let me point out that it will not always be exactly the same. For example, f of 1 equals 1, but preimage of 1 is not equal to just 1. Okay, and then finally we can ask questions like, is this injective or surjective? And for injective, we have seen that it is not injective, because here is an example where more than one element has the same image. So it is not injective because, for example, f of 1 equals f of 2. But of course, 1 does not equal 2. Is it surjective? Well, to tell if it's surjective or not means is the image of f equal to the entire codomain? This is another way of saying what it means to be surjective. And you can see that it is not. So 0 plus 1 over s, where s is a positive integer, certainly that is not the full real numbers. What is an example of something that is not in that set? No, for example, 2 is not in the image. So here's a nice quick review of all the kinds of things we can ask about functions.